Today on Engine Power, Mike and Pat are honored to refresh this 30-year-old blown big block Ford straight out of the most notorious truck in the world, the iconic original Bigfoot.
This year marks the 40th anniversary of the original monster truck. There can be only one, Bigfoot.
And it's unheard of that the iconic machine would ever pull into your driveway in need of a little help. That's right, the truck that started it all, Bigfoot One, is being dropped off by none other than the great Bob Chandler and business partner and longtime driver, Jim Kramer.
That thing looks awesome.
I want to see what those big tires on there.
She doesn't race anymore, but our team is going to get the chance to freshen her up, clean up the chassis, and do some much-needed maintenance. And more importantly for us, we get to rebuild this massive, blown, big block Ford that was state-of-the-art back in the day.
First things first, get rid of these skinny tires.
All right, Bob, we have Bigfoot One here, the original truck. It's retired from racing, but still does all the parades and that. But the rumor is this was your original truck back in '74, personal vehicle.
Yes, I ordered it from a dealership. Of course, back then they didn't have four-wheel drive vehicles, so it took 6-7 months to get it. And my wife and I used to take it, we'd go camping with it, put a camper on the back of it and take it down the river. But it went from the dealership to my house and the tires got changed immediately. That was the first thing that got changed. But it ended up being a vicious cycle because I put big tires on it and they weren't big enough for me, so I put bigger tires on it. Then I started breaking axles, so you put bigger axles in it. And then you run out of power, so you got to put a bigger engine. That's when I went to a 460 in it. It went that way for probably 3 or 4 years, where I just kept changing it.
4 decades later, Bigfoot is still a worldwide phenomenon, running 6 race trucks at a time, 3 more just for display, and even an all-electric Bigfoot. But there will never be another original.
A truck of this stature, you know, deserves a lot of credit. Something like the Smithsonian, is that something that could be in the future?
I would welcome it. We're still using it right now. Yeah, we hope it'd be great to do.
I think it would be the highest honor. I really do, because it, in fact, started the whole industry of monster trucks, which has become a great form of racing and family entertainment. And this is the truck right here that there was no other trucks, period, before this truck came along, and this man developed it. I mean, it started the whole industry. It deserves to be in the Smithsonian.
Well, now that we've seen the truck, for us as engine guys, we want to see the important thing. Let's take a peek at the engine, see what we have.
Okay.
Let's get a lot of hands on this big boy.
This is a piece of machinery right here.
Look at this thing.
Right there in the light, huh? Yeah.
Well, there she is, the original, huh?
Tell us a little history. This is automotive archaeology for us, because this thing's been around a while.
It actually started out life as a boat motor, supposed to be, and converted it to where we could use it. 640 inches. I forget the horsepower on it now, but had the NOS on it and everything.
How long has it been since it's ran?
Probably
Close to 20 years.
20 years.
20 years.
Really? Good running engine when it was pulled?
Yes, it was. I think you're going to enjoy this, because when you dive into this thing, it's like diving in the past.
Yeah.
You're going to see how engine builders did it many years ago. I mean, you guys are up to everything right now. You know all the new technologies and the metallurgy and everything else. Well, these guys had what they had.
Great. So it'll be interesting to see what's in there. I'm very excited to get inside.
And we got one of the best in the business.
And I want to say this too. I think, Bob, you kind of say this. If you got a good idea, something make it a little bit better, you know, we're not opposed to making a change here and there. We're really not.
We'll be very kind to it. Like Mike said, we'll treat it like it's our own. And we're just very flattered and honored to be part of, getting able to work on something like this. So.
Okay, you've been talking about this, so why don't we just quit talking and go to work?
Have at it. You're the boss.
We need to roll it to our shop. Say goodbye.
So long.
Next, we crack open this engine builder's time capsule.
In case you missed it, the original Bigfoot engine is here and ready for a complete refresh before it and the original Bigfoot truck go on display for good. Lucky for us, they trusted the Power Nation crew to freshen up and update this awesome piece of history. Pat and I get the engine, the original Allen Root 640 cubic inch big block Ford. Being able to participate in this piece of automotive history is way more than an honor. It was a dream just as a young child to make it to the local stadium to see those big blue trucks soaring through the air and crushing whatever got in their way. Now to be a part of the refresh of the original one that started it all makes that dream a lot larger than life. Now before we get started, Jim and Bob need a few more moments with the power plant that set the performance standard on 66-inch tires.
It was actually designed for a boat. I've never seen an engine like this. When this thing rolled in, I go, oh my God, what the hell is this? You know, I haven't ever seen an engine like this. Right. All aluminum block, aluminum heads. Look at the manifold, tall deck. You don't see stuff like this around the Midwest. We just didn't have that. The guys we ran with didn't have that either. They had big block Chevys or small block Chevys or Fords. That was it. Nobody had a specialized engine at the time. Nobody did.
Putting it back in the truck, it's going to be a kick for me. Just to see it in there, number one, but just to be able to drive it around is going to be spectacular. I know we've had people come in the shop that wanted to buy it, and if it was up to me, it's not going to be sold. At times we need money where we might have thought about it, but you know, that's Bigfoot. That's Bigfoot One right there. That's where it's got to go back in Bigfoot One. That's the only place it can go, as far as I'm concerned.
This is a rare opportunity to step back in time and see what was state-of-the-art in performance technology back in the mid-1980s. It's automotive archaeology at its finest. Plus, this combination has some unique parts specific to the application, like the Predator carbs, the BDS blower, the MSD magneto, and an external oil pump, and we'll cover those as it comes apart. Before monster trucks swapped over to injected engines, they all ran Predators. They're known to be the best off-road carburetor and have great characteristics like throttle response, excellent low-end torque, and a unique look that says performance. The only problem that arose with them was from inexperienced tuners. These things haven't seen the light of day in 20 years. We're going to be as careful with disassembly as we are with reassembly of this engine. We all know it has serious historic value, and we want to preserve every bit of that. Ooh, that is not your typical 4-barrel right there.
I've never seen the inside of one.
See, these plates, they don't particularly move. It's a variable Venturi type deal, which it just goes on air demand. It's a unique setup. There's not a lot of stuff that flops around in there, not a lot of moving parts in it. So
very cool.
To keep track of where everything goes, we're taking photos so we know what the untouched piece looked like.
All right, got all the linkage.
Very good, that's very important. This will ensure us the orientation of the plumbing and the exterior of the engine will go back the same way. We're also bagging all the parts and pieces for each component. This keeps the hardware from getting mixed up and costing us time later trying to figure out where things go. We're in the old 1, 2, 3 here. These Predators are extremely important to Bob, us too. They look great on the outside and all the linkage functions perfect, but we will give the internals a refresh.
Thing's a little dry, isn't it?
Yep. Sure is. It's
brittle.
20-year-old dust in there too.
Yeah. What's cool, they got the catch screen for any parts that come off up top, can't get into the blower rotors. The carb base is a 2-piece design, and we have to remove the upper carb plate first to gain access to the fasteners that secure the base to the blower. Now the custom NOS nitrous assembly can be removed. We're not sure what the horsepower level was originally. Now this engine will make gobs of power blown. Amazingly, they never needed to use it.
With the blower belt removed, we'll feel how well the blower turns over. It feels good, but there are a couple spots on the rotor that concern us, and it's an obvious sign of repair. The blower studs are aluminum and made to break away during an engine failure. If that happens, the restraint plate straps keep the blower from leaving the engine bay. BDS has been in the supercharger business for decades. This is one of their 871 units, which is standard on a monster truck, and we'll be sending this one back to them for a complete refresh.
The history lesson continues coming up.
We're back and ready to dig deeper into our automotive artifact. Now this is the original Allen Root 640 cubic inch big block Ford that set the monster truck world on fire back in the 80s. Now we've got it down to long block form, but it's not going to stay this way for long.
The tall deck cast aluminum manifold was built for performance, with nitrous bungs for a wet kit and a blow-off plate in case of a lean backfire. This thing was ready for serious power. Now we're starting to see the effects of it sitting for 20+ years. The cylinder head was ground for pushrod clearance, then epoxy was added to ensure water would not leak into the engine from the thin spots. It's obviously showing its age by separating from the aluminum. Aside from that, everything else looks pretty good up here. Now we can remove the dry rotted plug wires and the NGK spark plugs. Finally, the MSD magneto can be removed.
A magneto is a combination of a distributor and generator built into one. Unlike a regular distributor, a magneto creates its own spark energy without external voltage. They're used in engines that require high spark energy and can produce up to 20,000 volts. This engine came to us with the unique Allen root valve covers that were specifically made to fit his cylinder heads. Now the Hemi style is an eye catcher and we're leaving them untouched. It's their time to be removed and we can't wait to see what's underneath them.
Oh man, that's cool.
Wonderful.
Gasket came off in one piece. This is a gasket you cannot buy down at an auto parts store. It's unique to the Allen root setup. This is a Ford part number, but it's all Allen root and it's very unique, but it all looks good.
The valve train is specific to his design as well. Let's start with the intake side. It's a shaft-mounted rocker that rides on a needle-bearing fulcrum and has a large diameter roller tip to handle the high valve spring pressures. Now that large diameter roller also helps distribute the load due to the large amount of sweep on the lash cap because of that big cam.
What that means is there are more needle bearings riding on the roller tip's axle to distribute load. That equates to less friction and greater durability. The roller tip has a significant amount of movement on top of the lash cap, and it's under as much as 1,000 pounds of spring pressure. Keeping that big wheel rolling also keeps the valve guides from wearing out by not pulling on the valve and bending the stem inside the guide.
The stands are billet aluminum and made to a custom height which sets the valve train geometry for this ratio, which is 1.72 to 1. The rockers are also offset to allow port placement in the cylinder head. The exhaust side uses the same type of shaft mount, but they have a slipper foot on the valve tip because there wasn't enough material down here to put a roller and retain the strength. Now the reason they're so long, it's the only way to get proper push rod angle because of where the valve is placed in the combustion chamber. We're going to mark every piece of the valve train so it goes back where it belongs during reassembly. To do this, we'll use our Dremel, which is much more gentle on the parts than hitting them with a stamp and hammer.
Ooh, sheesh. That is not supposed to have a 1/2 inch of lash and any discoloration, so we're gonna have to investigate that further.
Come on with it.
We're gonna remove the rocker arms in pairs at each individual cylinder when they have no spring pressure. This applies to every engine. They come apart in a fairly unique way. By removing the Allen bolt, the shaft slides out of the assembly and the rocker arm can be taken off. Now that the stand bolt is accessible, we can remove it from the head.
No, I just bent the Allen.
Or so we thought. It seems 20-year-old Loctite is a force to be reckoned with.
Drowning it out.
I'm gonna mess something up right there. So the arms and the rods are priority. Again, keeping them organized. We also found the culprit of all that excessive valve lash. The number 8 intake valve is hung open, indicating it's seized in the guide.
With the long breaker bar, we can remove the massive 9/16" head stud nuts. In the reverse order they were originally torqued to. With only 10 in the head, they have to be large to keep the head clamped down to the block under high cylinder pressure situations.
Yeah, buddy, there it went. I heard it.
With a few swats of the rubber dead blow, the 20-year-old seal has been broken, and the driver's side head can be removed.
And it looks good. There's no signs of burns, leakage. It was doing its job.
And it looks like the passenger side did its job too. Not bad for a 29-year-old automotive artifact. We're back and continuing with the original Bigfoot's power plant. Now, just like us, you're discovering racing technology from over 20 years ago. Now, a lot of parts on this engine are obsolete and just flat out unable to get. So we'll be calling on some of the top guys in the industry who would have had their hands on engines like this back in the day to help us revive this piece of history.
This Mylodon crank-driven water pump is one of those long-lost parts. It's a cast aluminum piece that was found on performance engines in cars and boats. Now the pump can be pulled off the coupler and it can be removed. Next, the crank bolt is taken out to remove the coupler drive. These countersunk bolts retaining the blower pulley are being stubborn and won't come out. So a little backyard ingenuity is in the works. That's a proper term for a torch, WD-40, and an impact. Directly heating the head of the countersunk bolt will help loosen the Loctite. Due to the heat, the WD-40 is drawn into the void for extra lubrication under the head of the bolt. and the shock of the impact is doing its job to remove them.
Whee!
Success!
Wow, that was a little nerve-wracking.
Using our Matco balancer remover, we can pull off the timing wheel. Remove the supply line to the oil pump, and the original Aviade pump comes off, followed by the magneto drive housing. Now the Dually Enterprises oil pan comes off to expose the cylinder case. And at first glance, we're really impressed.
Back up front, the blower belt tensioner and bracket can go, followed by the timing cover specific to this engine design.
Oh yeah, that's cool.
Which reveals this highly specialized gear drive. Now, timing gears are very accurate because there is no chain to stretch. For reference during reassembly, we're turning the engine to TDC and documenting exactly where the alignment marks are. Now the entire gear drive can be removed. The camshaft is the next item to be disturbed. It's a solid roller from Howard's. Now it'll be upgraded to a more modern lobe design to give us more power and torque where it's needed in the power band. The rotating assembly is the foundation everything is built upon. We were lucky enough to get handed a folder containing the original build sheet, giving us the specs and manufacturers of all the parts in this engine.
The rods were built by Kramer, so we know they're strong. They're a forged and machined I-beam design. The big block Chrysler rod bearing, which is smaller than the stock big block Ford, translates to more strength at the big end and less bearing speed, which reduces friction. The pistons are custom Aries flat tops with 2 small valve reliefs. These gave this engine a 7.59 to 1 compression ratio with an 84cc combustion chamber in the heads. The ring pack is an 043 top, 16th second, and 3/16 oil ring. If you're new to the engine building scene, instead of spiral locks or round wire locks, these wrist pins are held in place by a free-floating aluminum button. This is not common practice anymore and will be replaced. The custom-forged 4750 stroke crank is held in place by extra beefy splayed 4-bolt main caps, plus a bolt hole in the center for this. An easy and safe way to remove them with a slide hammer. They're made of aluminum and hard anodized. They not only keep the crank in place, they add structural rigidity to the bottom of the block. Here's an oops we discovered. Too long of flywheel bolts were installed at some point and they self-clearanced on the back of this cap and block. The fix after these bolts were removed required helicoils to the crank.
The crankshaft is a unique piece from Arnold Forgings and has a cool story behind it. Larry Arnold designed the dies and had the forgings all done in Japan. The forging weighed 156 pounds raw and could make a big block Chevy, big block Ford, and a Hemi crank between a 3.6 and a 4.750 stroke. The quality of this forging was so far superior that their competition faded away from Pro Stock and Top Fuel, making this the backbone of the most powerful engines in its day.
So, do we have any question what we're doing with this engine? Nope. Jim's orders made it pretty clear.
I really want to see it run really bad. You know, I want to see it get back in the truck. I know Bob Chandler would love to have this thing in the truck. And I'd like to see that happen for him, to get this thing going and get in the truck and make the truck complete like it was, like it should be again. And this is the piece right here that's going to make that happen.
In the weeks to come, that's what we'll do. See you then.
It was Bigfoot that gave birth to the monster truck craze. Today, Mike and Pat continue the rebuild of its original blown 640, from battle scars to the machine shop.
We're back in the shop and ready to dig a little deeper into the original Bigfoot's power plant. That's because we get to refresh it and give it back to Bob Chandler so he can take the original monster truck Bigfoot One on its final tour before plans on heading to the Smithsonian.
This time it's not disassembly, but more of a CSI approach, which we'll call ESI, or engine scene investigation. We have the original build sheets, and our goal is to see how much abuse this engine has gone through and how much it's changed since day one. Take a look at what we found so far.
Last week, we had the honor to start the teardown of the complete Allen Root 640 cubic inch big block Ford that started the monster truck craze back in the 1980s. Now, this engine sat for over 20 years, so we started by removing each component and inspecting them to see what we had our hands on.
We all learned together that technology has changed and some of the items are no longer available. Now we ended with a bare Allen root aluminum block. After a 1-hour wash cycle, the aluminum block is dried off with compressed air and ready to go on the stand to continue our forensic investigation.
Giving it a good cleaning helps reveal details that weren't obvious in our original teardown, and we found a few things worth noting, like the first being a major repair in the lifter valley. A catastrophic engine failure caused this section of the block to be blown out, requiring major reconstruction. Compared to the architecture next to it, the difference is very obvious. A solid chunk of aluminum had to be welded in and machined to reconstruct the lifter bores and the oil galley that feeds them. That same failure caused an exit wound to the exterior that was also repaired by being welded up. The repairman even left his calling card with an impression of his initials and the date on the block. The damage was also on the inside. We're guessing the carnage was caused by a broken connecting rod because that's a typical damage path of that type of failure. Damage like that would undoubtedly destroy the sleeve as well, so it was replaced too. We also noticed a small repair to the deck surface. This discoloration you're seeing is actually epoxy that was used as a filler. Even more visual than that is this heavy gouging on the china rail. It's most likely caused by prying the intake manifold off during its years of service. During one of those prying sessions, a fastener must have been left in the rear of the intake, and this scar was the result. This kind of stuff happens when you're thrashing to get to the next round. Keep in mind, guys, battle scars like these are the result of years of competition with the same engine. These Allen root race blocks were made to withstand big power and lots of punishment. And out back, we already showed you the first discovery during disassembly. Too long of flywheel bolts were installed at some point, and they self-clearanced on the back of this cap and block. The fix after these bolts were removed required helicoils to the crank. There are several stampings on the block as well. These are the torque specs for the main caps. And also the original birth date when it was cast at the foundry, E2ZM. The E stands for the 80s and the 2 is for the year, so 1982. The Z designates Ford aftermarket parts, so don't expect to find this in any production vehicle. And the M indicates performance.
Even though this block was designed for racing use, it shares some common dimensions with the 385 series big block Ford, which was the 429 and 460, like the oil pan rail. The only difference in this one is it was scalloped for extra rod clearance, allowing this stock 429 460 gasket to still be used. The stock main journal housing size of 3.1922 is also used, and the same goes for the factory rear main seal. It also has the provision to run a stock oil pump, but an external line would have to be ran from here to the rear of the block, which is the oil inlet. Now that's because this block was set up to be either a wet or dry sump application. The cam tunnel is also in the factory location and retains the stock diameter. Now up here, even though we removed a magneto, the factory distributor hole is present, so one could be used. Also up front, if a couple of holes were drilled in the timing cover, a factory style water pump could be used. With all that said, this block is pretty versatile and can easily be made to run on the street. Now next, we're breaking out the measuring tools and getting technical. With the use of some micrometers and a dial bore gauge, the ESI investigation is digging deeper.
Next, size does matter, all the way to the thousandths of an inch.
Continuing on, we're turning the page to the technical chapter. Now tools like this micrometer and this dial bore gauge are what we need to measure the diameter of the engine's components. Now what we're looking for is to see how much this engine has changed from the original build sheet. So let's get started.
Making a build sheet takes time, but it's standard procedure for any serious engine builder. It's a blueprint of the entire engine, which is basically documentation. It's a sheet that we reference time and time again over the engine's service life. The original builder of this engine, Norm Grimes, did an excellent job on this one. The entire engine was well thought out, and we have evidence of it. He noted all the tolerances, as well as the parts that were used. He even noted the original job numbers from the manufacturers of the pistons and rods. The first thing I'm going to do is measure the bore size. It's at the top of the list, so it's a good starting point. Originally, it was 4/625. Let's see what changed. We'll have to set the dial bore gauge up to the original bore size. Using a 4-to-5 mic, we'll air set the size to 4/625. Air setting means you're setting the size of the micrometer without the use of a standard. Instead of relying on the tension of a part between the 2 points of a mic, you have to keep tension on it to get an accurate reading. It takes the backlash out of the threads inside the mic to mimic a part being in place. Now we can set the size in the dial bore gauge zero it out, and we're ready to measure. I'm placing the gauge in the cylinder about halfway down the bore, then slowly rock it back and forth until the needle on the gauge stops at its breakover point, which is the widest point, and the reading is 4.6303. That's almost 5.5 thousandths more than it started out, which means it was honed several times during its lifespan. We'll check every cylinder to find the largest one because that will help us determine what oversize we'll take it to on our freshen up. Ooh. And here is exactly why we do that. On the opposite bank, we found a cylinder that was over 9 thousandths bigger than the stock bore. It's not exactly surprising to find in an old war horse like this because sometimes you got to do what it takes to keep things running. And in this case, turn those 66-inch tires. Now the pistons are measured to see how much skirt clearance it has right now. That's the clearance between the piston skirt and the cylinder wall. According to the build sheet, the piston should measure 4.610. They are coming out 4.6095 because of a slight amount of wear. This is what the clearance was when the engine was first built by Norm based off the build sheet. They have 15 thousandths clearance. On the right side of the board is what the largest bore measures now, as well as what the piston currently measures. We'll subtract the piston size from the bore size, and that gives us a clearance of 25 thousandths, which is the worst case scenario, and that is excessive.
Resting on our Goodson measuring and inspection stand is the backbone of the Bigfoot One engine, and there's no mistaking it. Now it's got a 4.750 stroke, and we noticed that the rod and the main journals have been ground undersized to fix previous failures. For convenience, we're going to measure all the rod journals first because we'll have to relocate the stand to measure all the mains. Now using a 2 to 3 inch micrometer, we're going to measure the area where the rod bearing rides on the journal in 2 locations, one at vertical and one 90 degrees from that location. Now that method is going to let us know if that journal is out of round.
The vertical reading is 2.3633. 90 degrees from it measures 2.3630. Which means it's out of round 3/10 thousandths. This is important to find because the largest part of the journal is what's needed to set minimum oil clearance. The same procedure is done on the mains, and it's for the same reason. The first journal measures 2.9793 at the vertical reading and 2.9795 at 90 degrees, making it 2/10 thousandths out of round. Be sure to measure them all to make sure there isn't anything crazy going on. We found the journals to be all slightly out of round, but not bad enough to need regrinding. Now it's time to go to the machine shop for a good polishing. Our investigation has uncovered some interesting facts. Now we'll get it back to race engine status with the help of big block Ford guy John Kazi at Kazi Racing Engines, because this piece of history deserves the best. A huge contributor to success on the track is big, reliable horsepower under the hood. That's why we traveled to Winder, Georgia, and John Kazi Racing Engines to assist in reviving Bob Chandler's big block Ford. We did our own version of a forensic teardown, and this is what it's going to need. Replacing of the sleeves, align honing the mains and the cam tunnel, honing the board to size by using a torque plate, and O-ringing the top of the sleeves to accept new copper head gaskets. And the nice thing is, everyone we've called has been more than willing to volunteer their expertise to help get this iconic engine back between the frame rails, including the man with the skills and reputation for building the best Ford engines on the planet.
I really caught the bug about when I was 13. Lawnmowers, mini bikes, motorcycles, and then cars.
And since 1980, John Kazi Racing Engines has supplied our need for speed, with custom heads, intakes, and now turnkey engines. He's a Ford guy, just like his former boss, late pro stock legend Dyno Don Nicholson. Today, John and his team of experienced machinists lead the way in blue oval performance, on the track and on the street.
Just absolute genius. Comes up with ideas in the middle of the night, 3 o'clock in the morning, wakes up, starts taking notes. You come in the next day and it's a whole new project.
Like bringing the Boss 429 back to life with affordable replica packages that deliver from 500 to 1,000 reliable horsepower.
It's gone from a 2-man shop to a multi-million-dollar operation. We really enjoy what we're doing. All our guys here, we've got a really good bunch of guys. Everybody comes into work pretty happy, enjoys what they do, and we have a blast.
It's all about bettering technology, which is why we entrusted Kazi with the Bigfoot first-gen Allen Root block.
Those blocks were a little bit on the flimsy side. You know, the bores were really big for the sleeves. They tend to move around a lot and the bores wouldn't they wouldn't stay round. We took all the sleeves out and cleaned everything up. Then we had special sleeves made that we put in. But the sleeves themselves are real thick wall. And well, that means the bore is smaller, but when you're working on a supercharged engine, you know, the last little bit of cubic inch that you got from the bore size, I don't know if it's really that important anyway, because you almost need more blower to fill it up, you know, and I think that probably rounder bore and a few less inches would be way better than more cubic inches and all the air going by the rings.
With the block back to ambient temp, Chris Thomas can proceed with the align hone process. This will ensure all the main bores are the same size and in perfect alignment. First, Chris will set up his dial bore gauge to 3.1930. With the mains torqued to 85 foot-pounds, he'll measure to see how much has to be honed out to get to the correct size. Now the appropriate mandrel is put in, and with the tension set, he can begin. Material comes out fast with aluminum, so it doesn't take long before the job is complete. Switching to a smaller mandrel, he'll do the same operation to the cam tunnel, finishing them at 2,250.
That block's had more than one accident in its life. We can see some welding in the valley and stuff and on the outside, and we don't know exactly where it's been and what it's done, so we got to check a lot of that stuff.
The machining continues, along with massaging the heads.
Today we're in Winder, Georgia at John Kazi Racing Engines, a world-renowned high-performance engine shop specializing in big Ford power.
Everybody that we've got here essentially can do all the jobs. Everybody has the ability to do the machine work, do the assembly, dyno work, and really do a really good quality job of whatever we do.
Before getting started, the hone's guide shoes and stones have to be set up for the engine's bore size. Using a cylinder gauge and shims, it's an easy task. Now Chris will install a torque plate and tighten it down to spec before honing starts. The plate simulates the stress of a cylinder head being on the engine, which can distort the cylinders out of round. That affects ring seal and ultimately power. So honing with a torque plate attached ensures the bores stay straight and round, maximizing horsepower potential. When all said and done, the final bore size in this beast is 4,377. While the block gets a quick bath, veteran machinist Ron Baker checked the crank for cracks. Then use the Goodson polishing machine.
You have to be a little careful.
To clean up the journals. Then onto the boring bar to get O-ring grooves cut for the use of copper head gaskets.
10 at 0.
A 4/600 diameter groove is cut to 27 thousandths deep to accept a 39 thousandths stainless wire. This seals in the combustion of the big blown Ford. Chris, performance machining is as much as an art as it is a science. Honored to be a part of it. We made a quick trip down the street to John Kazi's trusted cylinder head guy, Chris Howe of Howe Racing Heads.
A valve job, the seating area is one angle. In a competition valve job, we'd run multiple angles, and you're trying to increase the airflow. And if we increase airflow, you increase your horsepower. You can't have any run out. You have to have a valve job that seals. You don't want leak down or leaking valve seats, so everything's got to be precise.
Before starting, Chris had already put new liners in the intake guides and set up the proper clearance. Any competition valve job has very specific angles per the application. In multiple stages using different cutters, the angles are as such: a 35-degree top cut, a 45-degree seat angle, a 65-degree bottom cut, and a 75-degree bowl cut. This will give a good balance of power and longevity to Bigfoot's AR Hemi heads. Onto the exhaust side for the same operation. The difference being the top cut is changed to 32 degrees and the radius cut is under the 45-degree seat cut.
All right.
After all of the machining is finished, Chris will check the seat contact by lapping the custom Manley valves to the seats using fine lapping compound.
There you go, that's a beauty.
That wraps up the heads. Now back to Kazi's to pick up the block and crank and hit the road.
We're trying to restore it back to original running condition. And I don't think the last bit of power in this engine is going to be really needed anyway. I think it wants to run good and be dependable and not leak water into the oil, not leak combustion into the crankcase, stuff like that. So we're trying to make it a nice drive-around engine for the Bigfoot people.
Perfect. Guys, it's a pleasure. Thank you very much. You've helped us immensely. You've helped with a piece of history, and I think it's going to run great, and I was very happy to have you guys part of it. So
we're glad to be part of it. It's a fun job.
Thank you very much.
Yep.
Yes.
Hope it works good.
Hopefully you'll be able to hear it run. I'll keep you posted on the progress.
All right. Well, if you get bored, bring it back. We'll run it.
All right. I appreciate
Okay.
that. Thanks.
Today on Engine Power, from 2 decades in storage to the Dyno, the heart of original Bigfoot restoration is completed.
Welcome to Engine Power and the show most of you have been waiting for. Today is final assembly and dyno of the original Bigfoot One's power plant.
Our goal is simple: to make an engine that makes big power, that's reliable, but most importantly, retains the aesthetic so it looks the same as it did back in the 80s. Here's a quick look at what got us to this point.
Why don't we just quit talking and go to work? Have at it.
Mike and I took delivery of the original 640 cubic inch Allen Root big block Ford with simple directions: don't hurt it. So we disassembled it, taking notes and learning about the technology that was used 30 years ago. Then we enlisted the best Ford engine builder on the planet, John Kazi, to do the machine work and get us ready for assembly.
If you're new to this project, the foundation is this Ford Racing aluminum big block designed by Allen Root. Now it shares the same characteristics as Ford's 385 series engines, which was their 429 and 460 big block. It has a 4.377-inch bore with the freshly installed sleeves from Kazi. Now they're a little smaller than original, but we gain tons of rigidity in the block structure due to the thicker walled sleeves and that smaller bore. Billet aluminum 4-bolt main caps will keep the crank in place, and they have to be removed for us to get started. Going in the saddles are Cleveite P-series bearings. Making sure the saddles and the bearings are as clean as possible using a lint-free paper towel is crucial.
Here's a quick tip: never use red shop towels to clean engine parts when assembling. They're cotton-based and shed red lint, which can wreak havoc in a fresh engine. Out back, the upper half of the Fel-Pro rear main seal is laid in. Same with the bottom half. This 90-plus pound forged billet steel crank has a 4750 stroke and is internally balanced. It's made specially for this engine and can take any punishment we're going to throw at it. Now the main caps can be filled with the other halves of the bearings and then placed over the main studs. A rubber mallet is then used to seat the caps in the registers. With extreme pressure lube placed on the nuts and washers, we'll snug all the caps and only torque the center one, which houses the thrust bearing. Now, using a magnetic base and dial indicator, we'll check the crank's thrust, which is how much the crank can move front to back. We're looking for 4 to 9 thousandths. It's 6 thousandths, so we can go ahead and torque the rest of the caps. First 30, then 55, and the final 85.
Next up is the time-consuming task of file fitting the rings. Now here's a quick tip. Start by filing the second compression rings first. Now it sounds strange, but here's the logic behind it. It gives you a chance to get a feel for what you're doing. The second gap is crucial, but not as critical as the top rings. Now we're doing the second and first rings at 7 thousandths per inch of bore, which will put us in the 30 thousandths range.
Custom engines require custom pistons, and for that we went to one of the best in the business, CP Pistons. They built us a forged aluminum flat top with dual valve reliefs, and these are the same forgings that they use in alcohol funny cars and dragsters. We started by sending them a sample from the old engine. They redesigned it to meet the needs of our updates and the increase in power we're going to see. They retain the original 1031 pin diameter, and those are held in by double spiral locks instead of the old aluminum buttons. They have ultra-precise ring grooves, and they're set up for a 16th, 16th, 3/16 ring pack. The oil ring is supported in the pin boss by a support rail to eliminate any oil control issues, Plus, it's still a full slipper skirt design with a super smooth finish to reduce friction.
When you have a good thing, why change it? Now we're going to hang those new pistons on the original Kramer rods. Now these things are a forged steel I-beam design and have a 7/150 center-to-center length. Now they'll support in excess of 1,500 horsepower, which is way more than we'll ever need. The pins are lubed up and will make the link between the rod and the piston. Now making sure they stay put are double spiral locks. Now the only thing we can say about them is take your time as you roll them in place. To complete the piston and rod assemblies are the custom total seal rings. First to go on the piston is the oil support rail, which has a dimple in the surface to keep the end gap from rotating into the pin boss. The 3/16 oil ring has chrome-faced rails for durability, and the expander is a standard tension for supercharged applications. The steel Napier second ring is next. A Napier ring has a sharp hook on the edge to actively scrape oil off the cylinder wall. Finally, the C33 steel top ring. Now these complement the super accurate ring grooves by maintaining a flatness of less than 50 millionths of an inch. With the rings in place, we'll use Royal Purple break-in oil to lube the pistons. Now the Cleveite rod bearings can go in, get lubed, and using Royal Purple break-in oil, the cylinders are lubed as well. Our Total Seal tapered ring compressor will allow the number 1 assembly to slide into its new home. With extreme pressure lube on the nuts, we can tighten the rod cap into place. This same procedure is done for all 8 cylinders and requires a little bit of patience. All right, Pat, last one, number 8.
Home stretch.
Nice.
Now the rods can be torqued to 65 foot-pounds. And with that, we have a short block, which gets us one step closer to the dyno.
Big cubic inch engines require special specifications, and there are no secrets here. Now the guys over at Comp Cams designed this bump stick, which controls the opening and closing of the valves to maximize that engine's capabilities. Due to the stout spring pressure we'll be running, we're using Comp's cam lube on the journals and the lobes. Duration at 50 thousandths is 277 on the intake, 289 on the exhaust. Lobe separation angle is 113, and gross valve lift is 824 and 800 respectively. On its snout is a cam thrust plate just like a 429 and 460 engine use. And in front of it is the hub for this engine's gear drive. Now here's where the photos we took during disassembly come in handy. We have to make the link from the cam to the crank, so using the original gears, those pics assured us it's going back together the same way.
Degreeing the cam is assurance the camshaft is operating the valves at the precise times it should be. Our cam card states it should be installed at 113 degrees, and we verified that, so there are no questions.
Big engines need big flowing cylinder heads to make good power, and that's just what these Allen Root aluminum Hemi-style heads will give us. Now these things saw a lot of abuse in that monster truck over the years, but the little trip they took down to Kazi Racing Engines got them back in order. Here's a look at the treatment they received. The intake runner's roof was way thinner than Kazi liked, so he had his guys add more material in the rocker stand's pad, then they machined it back down, making this area a whole lot stronger. They also received new valve guides, and they replaced the epoxy on the push rod holes since the original stuff was flaking and peeling off. A competition valve job was also performed, which will help the head flow better numbers. To get them in working order, we called Manley, who set us up with all the components to get them put together, like seals, locks, wear caps, retainers, and spring cups. They also sent us their signature custom Gen 2 severe duty intake and exhaust valves. Now the NK844 material used in the intake valves and the XH428 material used in the exhaust valves are not available by anyone else in the world. Now that makes these things up to 4 times stronger than anyone else's offerings. Now sizes are 2/400 on the intake, 1/900 on the exhaust. The valve springs are their Next-Tech double spring design that doesn't use a dampener. Now diameter is 1 inch 640.
First to go on is the ID locator spring cup, followed by the Viton valve stem seal. Now the stem of the valve gets lubed with Max Tough assembly lube and slid into place, making sure to rotate the valve so the lube coats the entire guide and seal. Now the spring is put into position and topped with a titanium retainer. Using the Goodson spring compressor to compress the assembly will allow the valve locks to be put in. With the others completed, the heads will be ready to go on. For gaskets, we wanted the best we could get our hands on, so we sent all the originals from this engine to Cometic Gaskets. They use their in-house tooling to remake all of them using the latest and high-tech materials. The head gaskets are made of copper and have a 4.385 bore and a compressed thickness of 43 thousandths. VHT's copper gasket cement will coat the top and bottom to ensure we don't have any leaks around the water jackets. This is a must for single-layer copper gaskets. With them in place, we can position our head over the 9/16 studs and guide them to the deck. With extreme pressure lube on the nuts, we'll torque the head in stages till we reach 110 foot-pounds. Here we go. Which requires an anchor man, literally. Victory. Whew. Now it's starting to look like an engine.
Yes, it is.
Coming up, the build continues.
We're back and have made good progress in the resurrection of Bigfoot's original engine. From the crank, pistons, heads, and cam. Now, riding on those lobes are Comp's Endurex mechanical roller lifters equipped with a vertical link bar. They're fully heat treated, machined to ultra-high tolerances, and are even rebuildable. We inspected the push rods and gave them the green light. With lube on the tips, the rocker assemblies can go on in the engine's firing order. The intake rocker stand is first, which is secured with a countersunk bolt in the center. And with the outer fastener to align it, we'll torque it to 25 foot-pounds. Now the wear cap can go on the valve tip and get lubed. The rocker shaft assembly drops down now, and the shaft is pushed into the stand. Kazi added a third fastener for additional strength, which goes through the shaft and the stand. This spreads the load out across the entire assembly, making it stronger. We'll set the intake's cold lash to 10 thousandths since this is an aluminum block and head configuration.
Now place a lash cap on the exhaust valve as well. These stands only use 2 fasteners. Now the arm is uncharacteristically long due to the exhaust port's location. We'll set the lash to 12 thousandths. And of course, there are 7 more cylinders to go. In order to install a timing cover, we had to have the magneto drive gear and housing. Well, luckily it just got back from System 1 Pro Ignition, where they custom fit this MSD Pro Mag 12 into the original Allen root housing that had a Vertex in it. To do it, they had to replace the lower housing and this shaft for a new number 4 unit inside the MSD. Now the reluctor was also reclocked to work with the counterclockwise direction of the MSD setup. They also installed a new Mallory 4-pin driver and lockout. Here's what the old one looked like. They even glass beaded the housing for us and supplied a new band clamp to mate the two together, making this the go-to source for any mag work. Now we can install the mag drive gear, which rides on a captured bearing in the block, and pre-lube the entire drive with Comp Cam's valve train spray. Now we'll run a bead of gray RTV silicone on the timing cover's mating surface. Finally, the timing cover can be reunited with its counterpart. And the blower's tensioner bracket can be installed, which houses the fasteners for the cover.
Now the timing wheel can be installed onto the crank snout, followed by the alternator pulley, and finally the blower drive pulley. The Allen root mag housing can go on now, which leads us underneath to mount the oil pan. With a one-piece gasket in place, the original dually oil pan can go on to seal up the bottom end. Back up top, we'll dress the head side of the Cometic intake gaskets with Loctite high-tack sealant. Lay them down and apply silicone to the china rails for a leak-free seal. One more thing.
Beautiful.
That's only important to us.
Nice, nice, nice.
Hey, you would too.
Finally, the mammoth blower manifold can go on and is tightened in a crisscross fashion to 35 foot-pounds. Slicking up the springs, trunnions, and roller tips is Comp's valve train assembly lube. And to seal all this up are more Cometics, which are sandwiched by the original cast aluminum valve covers. Another component we had to send out to get rebuilt is this external oil pump from Aviade. Now they replaced the relief valve and a bearing or two, but other than that, it was in really good shape. And they got it back to us within a week. Thanks, Aviade.
It attaches to the mag housing and is driven by a hex off the gear. Blower Drive Service, or BDS, serviced this old Mooneyham 871. Now that included replacing the blower drive hub, all the bearings, and inside they replaced the seals. Now BDS also sent us the correct length blower belt for our pulley combination. This rubber coupler makes the link from the crank to the crank-driven Mylodon water pump. All new Earl's fittings and hoses dress the engine's cooling system.
Now
a gasket and the blower.
the
nitrous
hold on,
plate.
we have all this, we have a picture of that somewhere.
And again,
The
documentation rules.
nitrous plate was the highest. It goes gasket, hold down bracket for the blower, and then the spacer, then the nitrous plate, then the top end. I can't wait to hear this thing run. I cannot wait.
It's gonna be awesome.
And that's the plan after the break.
You've waited for it, so stay with us.
We knew you'd wait for this moment. After all, this engine waited 23 years for it. We've put a large amount of time into this restoration, along with Summit Racing, who saw its historic value as well. 23 years since exhaust cooked these headers. Water rushed through its cavities. Fuel and spark exploded in its chambers. The refurbished MSD Magneto will generate the spark, carried through their 8.5 millimeter wires to V-Power racing plugs gapped at 12 thousandths. The fuel is fed through the 3 original Predator carburetors, refurbished as well by the same company that made them in the early 70s. Wide open's right there.
In fact, everything is original, except a short list of internals. With oil being pressurized in the block and the fuel line connected, the 23 years of silence is about to end. Ready?
Contact, clear prop.
Nice! We had faith it would run, but that quick fire up was a surprise. Idle and a little high. So after setting the timing at a safe 26 degrees, we'll shut it down.
You know what?
Woo, that was a fire up.
That was a fire up right there.
Nice. Celebrate again and adjust the Predator's linkage.
We also noticed the air-fuel ratio was too rich, so each carb needed a slight but equal tweak to the recessed adjustment screws. A lot of teamwork involved in this. And we'll try again, this time to warm it up for a final inspection. There, now we're talking. Now it idles.
After 10 minutes on 116 octane, we can confirm the valve lash settings. With no leaks, no knocks, and no flames, we'll make a conservative pull from 2 to 4,000 RPM.
Ready? All right, on to glory.
Not bad.
Hey, that's lit torque, 777 foot-pounds of torque, 588 horse. We have almost 16 pounds of boost right now.
Almost 16 pounds. And climbing.
And climbing.
Here goes another at 1,000 more RPM. 750 horsepower, 795 in torque. And big torque is what makes a monster truck a monster. And we're stopping here for good reason.
We're not trying to kill it.
No.
It needs to motivate the truck, and I think it's going to do that just fine.
With 1,000 more RPM in the sweep, it made an additional 200 horsepower. And at that rate, it'll make 1,000 at 6,500 RPM. But this build wasn't about making max horsepower or max RPM. It's all about getting that power plant back between the frame rails of the original Bigfoot One.
From here, it's going to go next door to Truck Tech where the install is going to happen, and that gets us one step closer to the driver's seat. Then you may be able to see it on its final tour around the country before it hopefully goes to rest at the Smithsonian.
Today, we've got the original Bigfoot in the shop. It's the truck that started the monster truck craze nearly 40 years ago, and we're using our overhead crane to reinstall its original blown 640 big block. After nearly 30 years apart, Bigfoot will roar again with its original monster power plant. It's all today here on Truck Tech.
Hey guys, welcome to Truck Tech. Well, today we've got something very cool, unique, and obviously huge in the shop today. This is the original monster truck, Bigfoot #1. Now, just to get it through our shop door, we had to take it off of its giant and heavy 66-inch tall monster truck tires and put it on these relatively small tires. Now, the reason it's here is so we can drop in a new engine. What you see on the engine stand is the original 640 cubic inch big block that powered Bigfoot back in the day, and it's been rebuilt by the guys in the engine power shop. The foundation for the build is an aluminum Allen Root Ford Racing block, and it's topped off with a pair of Allen Root aluminum Hemi style heads. The gasoline and air mixture is lit off by an MSD magneto that was set up by the guys at System 1, and well, this giant belt is not for turning an alternator. It's to turn this giant polished supercharger that's been freshened up by the guys at Blower Drive Service. Sitting on top of it are 3 massive Predator carburetors. Now, this combo on top of the engine is good for about 20 pounds of boost and about 1,000 horsepower, and that is without any nitrous. Now, in between the freshened up 640 cubic inch race engine and Bigfoot's huge heavy-duty military-grade transfer case is just a Ford C6 3-speed automatic transmission. Nothing too exotic, which is kind of surprising since Bigfoot probably weighs around 15,000 pounds and everything else is custom or oversized. Now, the guys at Bigfoot typically build their own transmissions in-house, but we figured since we're installing a rebuilt engine, we might as well install a new transmission as well. So we gave the guys at TCI a call, and they put together this custom-built trans just for our application. Now, like I mentioned, this is custom-built, but it's based off of their Super Street Fighter Ford Big Block trannies, rated at 875 horsepower. This one features a deep cast aluminum pan, a full manual valve body, a billet servo, and high-energy clutches, along with a handful of other upgrades. Now, in addition to the trans, we also picked up one of their Street Fighter torque converters. This one has an anti-ballooning plate, thrust bearings instead of washers, it's computer balanced, furnace brazed, and it has the smaller diameter crank pilot to match our aftermarket crankshaft. The first thing we're doing is filling up our converter with TCI's Max Shift Performance transmission fluid. And after making sure the input shafts were in the correct spot, I installed the converter, rotating it while applying a little bit of pressure, making sure the torque converter is fully seated. Cool, there we go. Then we added the separator plate. And since Summit Racing is a longtime sponsor of Bigfoot, we went to them for our Mazir SFI-approved billet flex plate. Installed it and torqued the bolts to 80 foot-pounds. Then, using our crane, we floated the transmission into position, loosely installing the bell housing bolts while making sure that the torque converter studs were poking through the flex plate. Then, I tightened up all the bolts. Oh, this thing is ridiculously huge. And to get this aluminum V8 high enough so we can install it in Bigfoot, there was only one tool in the shop capable of getting that job done, and that's our overhead Cundle crane. We couldn't have done this job without it. And believe it or not, wrestling this huge engine and transmission into place while over my head was a one-person job. You can't do that with a cherry picker. And after climbing all over this thing, lifting, strapping, pushing, and pulling, I was able to wrestle this engine and transmission combo into position. Come on. It was a little bit easier than I thought. All right, it's home. It's been a while, probably 20 years since this engine's been sitting in there. Now, the next thing we need to do is get some exhaust on this thing. Now, these headers came to us with the freshened up engine, and I'm pretty sure they are the original headers that were initially installed with the 640. They've got 2¼ inch primary tubes, a 4-inch outlet, and I assumed they were some hand-built headers, but it's got Hedman headers and Bigfoot stamped right into the flange. So, at the very least, we know we've got the right ones. Now to seal the headers to the heads, they don't use gaskets. They just rely on some Loctite high-temp copper silicone to get the job done. A bead around each port is more than sufficient. And this stuff's good up to around 700 degrees. Cool. And to secure the headers, I'm using some nice ARP 12-point header bolts. First, I ran the bolts in and snugged them down, and then I did the final tighten by hand. That way I can get a good feel for it and won't risk over-tightening these small bolts. Then I can move on to installing the transmission dipstick and pinning it down using one of the bell housing bolts. Then I can reinstall the heavy-duty transmission cooler lines. Done, 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 done.
After the break, we'll add the supercharger and install the drive shafts. And later, we'll start this monster. Stay tuned.
Hey guys, welcome back to Truck Tech. Well, we're in the middle of reinstalling the gargantuan big block that Bob Chandler and his team at Bigfoot dropped down in between the frame rails of this old Ford some 35 or 40 years ago, way before monster trucks and Bigfoot were household names. Now we've got the engine bolted to our new transmission and locked into place. And we've reinstalled the original headers that first were bolted up to this giant engine. Now the reason it makes so much power is not just because it displaces a monstrous 640 cubes. It's also because it's got a big old supercharger strapped to the top of it, cramming air into the cylinders. After installing the manifold O-ring and gasket, I can start lowering this polished power adder into position. Now to handle this thing, we're using the Pit Pal engine hoist that we picked up from Summit. And I've got it bolted to the supercharger, so that's preventing me from fully installing this thing or lowering it into position. So I'm going to set it on a couple of pieces of 2x4, remove the straps, get the crane out of the way, and go recruit some help. Ready? Holy crap.
All right now.
Feels like you've got most of the weight, Pat.
Just trying to go nice and easy.
Right. All right.
Success.
That wasn't so hard.
No. Right there's 100+ pounds of blower.
Yep. Thank you, sir.
You bet.
And with that done, I can secure the hardware that holds the blower in place. Being careful not to over-tighten it. They are aluminum studs after all. Then I can add the blower drive belt and tension it. Now it needs to be good and snug, but not guitar string tight. It's got to have a little play in it. Probably good. Then using the 1/2-inch drive on the front of the blower pulley, I can finally roll the engine over so I can gain access to the 4 torque converter studs. All right, there's one. At least I can see through the starter hole. Kind of convenient. Then, one at a time, I can tighten up the torque converter nuts that have seen a couple of drops of blue Loctite. Then I can attach the transmission to the rest of the drivetrain using the drive shaft for this divorce mount transfer case. Now the drive shaft itself looks like your typical run-of-the-mill light truck drive shaft, just one that's been shortened. And it's all it really needs. The drive shafts don't get really big until after the gear reduction of the transfer case. Now we've installed drive shaft safety loops before, kind of like these, but this shield here is probably bomb-proof, and it's what goes around the drive shaft that goes in between the transmission and the heavy-duty transfer case. This thing is serious. Now this shrapnel tube not only protects the driver from exploding parts, it also keeps flying drive shaft chunks from heading their way into the spectator stands. But it doesn't look like it was ever tested. That's a good thing. Now, in addition to installing the rebuilt supercharged big block and new transmission, we're also going to be updating the fuel system on Bigfoot. So we went to Aeromotive and picked up one of their Phantom Universal Electric in-tank pump kits. Our kit includes a 450 liter per hour electric in-tank pump, which is a great match for the power output of the engine. The electric pump hanger has inlet, outlet, and vent ports in a -6 size, and the pump hanger bracket is trimmed to fit so it can be retrofitted into just about any tank. It also includes a fuel-resistant foam baffle and a rubber bladder to assist in fuel pickup. We also got one of their fuel filters and fuel pressure regulators. And to make sure the installation goes smoothly, we picked up enough fuel line and fittings so we can feed the beast under the hood.
Up next, we'll run the fuel lines and then we'll fire it up. Stick around.
Hey guys, welcome back to Truck Tech. Well, we've got our new electric fuel pump installed inside the tank, which is in the truck bed. And we've got the braided stainless steel line passing through an existing hole in the bed floor. And now we can add our fuel filter, plumb the line up to the engine bay, add our adjustable fuel pressure regulator, and get everything plumbed. Now, installation of the fuel filter was really simple because they already had this bracket bolted to the bed floor. So we just simply clamped ours in place. Then added the input fuel line and the output line heading to the engine bay. Then to hang the fuel pressure regulator on the firewall, I'm using one existing hole and making one new one. Then I can add the anodized regulator and start routing lines. Now this heat shielding was on the fuel lines when it came to us, so it's going to go back on the new lines as well. My guess is those headers make quite a bit of heat, so a little bit of heat protection will make sure the fuel doesn't boil on its way to the carburetors. I think we're gonna make it. All right, cool. This is the return line, and this is the feed line. Now to snug the fittings down, I'm using an aluminum AN wrench. Now these are the original braided fuel lines that went from the carburetors to the feed line on the firewall. And years ago, blue and red anodized AN fittings were pretty much all you could get. But the new section of fuel system uses black anodized fittings. So rather than come in here and switch those dozen or so blue and red fittings to black, we're just gonna run the original fitting on one end and then just add a black fitting on the other end that attaches to our new regulator. Now, if you've never assembled an AN fitting before, the process is fairly straightforward. And most of the time, you can get the braided line started by hand. If not, Cool Tools makes some pretty cool tools to help you out. You want the braided line to almost bottom out on these threads here. That way it's fully seated before you put the other part in. Slick them on here. Will help this assemble. Make sure you're holding the braided line on the bottom and the fitting at the top is not pushing it out. All right. Now the fittings on either side of the regulator is what is going to feed our 3 carburetors. And they're both regulated pressure. To make adjustments to that regulated pressure, you simply use an Allen key on the top of the regulator and lock it in. Now this braided line is pretty tough, but we still don't want it bouncing around the engine bay. So I'm zip tying the stainless flex line to the stainless hard line of the nitrous system. And after snugging down the zip ties, a razor blade makes sure there's no leftover sharp edges. Hey guys, welcome back to the shop. Well, we've got this monster of an engine mostly underneath the hood of this old Ford. And this engine hasn't been installed in this truck for over 20 years, so it's pretty cool to be able to reunite the two. Now we've got the supercharger hooked up, exhaust installed, fuel system installed, our fuel pressure regulator dialed in, and everything seems to be good to go. So we're going to dump some fluids into this thing, see if we can make a little bit of ruckus. To fill up the transmission, we're using a couple of gallons of TCI's ATF. AutoZone provided the coolant for the giant radiator, and we went through about 14 quarts of Royal Purple's XPR 20W50 race oil. This thing's thirsty. All right, well, time for the moment of truth. Now, I've got Pat from Engine Power helping me out. He had this thing running on the dyno, so it only makes sense to have him give me a hand to get this thing started. Let's give it a shot, man. You ready?
All right, let her rip. Oh, come on, baby.
Ready?
Yep.
Well, that beautiful sound tells me that this project is a success. Now, I'd love to throw the big tires on this thing, take it out on the field, and thrash on it. But it's the original monster truck. Probably not that good of an idea. So if you guys want to see more of this thing, go to Bigfoot4x4.com and find out when it's coming to your area. For now, I'm going to give Mr. Bob Chandler a phone call, tell him his pride and joy is ready to be picked up.